And this is going to take the first parameter of that. All right, so this is giving us a reward if we are correctly predicting our target. This is based off gamma, so changing gamma will change what type of rewards we get, which again makes sense since the gamma is the discount factor, or controlling whether or not we want to value current rewards or future rewards. So that's the start, but we're not quite done in this function here. So that's our Y target, but we also have an X batch here, and we want to append the state, so that keeps growing, and the Y batch dot append Y target is 0. There we go. All right, and we're going to use this information to train our model. So this is where the actual training comes in. We're going to have the numpy array based off the X batch, np.array Y batch, batch size, and verbose is just whether or not to be making print statements off of this. And I have an extra parentheses in here somewhere. I forgot one here. There we go. Let's take off this extra guy. There's that. And we want to update our epsilon each time because we want to progressively get less explorative. So as long as we're still greater than our epsilon min, what we're going to do is epsilon times equals. So this is going to be the current value of epsilon times our epsilon decay. So this is going to be reassigning the value of epsilon to whatever it was previously multiplied by our epsilon decay, which if you remember we defined up here as 0.995. So it'll decrease slightly each time it goes through this. So each time we call the replay function, we'll lower our epsilon, we'll fit our model based off of whether or not we're getting a good reward. So these are our nice setup functions that we're going to use all the time. But now we're actually going to have to progress to defining a run function, which is actually going to run through these and train the network. So let's make sure those compile. Yes, they do. So that's good. We can move on. Define run functions. So this is going to record the environment state and use our network to choose the best action to take. So let's define this here. Run, we don't need any parameters into this. We're going to have scores that we're going to keep track of, and this is going to have a much smaller max length. So for E, and E here is going to be our episode. So that's why we're going to have the number of episodes here. We're going to get a state. We're going to pre-process this. So we're going to use our function that we defined above, environment.reset. So we want to start from the beginning each and every time. We want to make sure our done is equal to false, and we're just going to have time step equals 0 here for I. So while not done, so while done is false, which it is now, we are going to take the following actions. So first one, action, is going to be choose action, state, and based off our epsilon for that current episode. So here we have our action, calling the choose action function, which remember is taking a random action from the sample space if we have a high epsilon, but otherwise it's going to be using our model to predict what action we should take based off the current state. So that's what we want. And then what we're going to get, so next state, the reward and done, and we'll just leave this blank here, is going to be equal to environment.step based off this action. So this is the OpenAI environment taking one time step forward. And let's render this as well so that we can see what's going on. So next state is going to be equal to pre-process state next state. So we have to pre-process that again. And this is why we defined this earlier, because it's coming up a lot of different times. And we want to remember this information because it's going to go into our memory. Next state and done. There's that. And remember, let's hope that I can spell it right. State is going to be now our next state. So we took that action and we are going to bump up our time step 1 So plus equal, just like the multiply equal, it's going to take the current I and add 1 to it and reassign that to the value of I. So there's that. Oh, too many tabs here. So after coming out of this while statement, we should have done now. So it's finished. The poll either tipped over or we hit the max number of ticks. So we're going to have a scores.append. We'll keep track of our scores here. And so our score is simply how long we stayed up. So the number of ticks that we stayed up. That's why up here we defined our number of winning ticks as 195. So if we can go through this process 195 times, choosing an action and processing and rendering the state based off that action 195 times, we'll get a done statement. So let's append that score. We're going to take the mean score so that we know we're not just getting lucky one of the times. And then so we can have a couple of if statements here to print stuff out depending on what we get. So if mean score is greater than or equal to our number of winning ticks, and we'll also throw this in there just to make sure nothing happens right when we start. So we'll make sure we go a couple episodes. If not quiet, which is why we had the quiet statement up there before, print ran, and we'll use the dot format notation here again. Ran episodes solved after trials. So that's what we want. And here, remember, no period yet. We can go dot format and then substitute in E, which is our episode, and then E minus 100 will give us the number of trials. All right. And we're also going to have a return E minus 100 as well. All right, we have an if statement here. So if E is divisible by 100, evenly divisible by 100, and not quiet, what we want to do is we want to print the episode. So we'll say episode. So we'll print the episode number, and we'll say mean survival time over last 100 episodes was ticks or time steps. So we'll have that. Dot format again. So episodes and then our mean score. So there we go. So actually, I'm going to change this to 20. This would print this out every 100 episodes. That's going to take a little bit, so we'll do every 20 episodes just so we can see how the model is doing more frequently. All right, so let's move on into our replay, our all-important replay function here. So I'm going to do replay, batch size, and epsilon, so we can actually train the network based off the results that we got. Then we can do one more. We'll say if not quiet, print did not solve after blank episodes. So this is sad. We hope this doesn't come up. But we don't want our model to run forever if it's not converging. So we'll include this in here. We'll return the episodes as well. Okay, so here we have our run function. We have all the functions that are used within the run function, and we are choosing an action based off the current state. We are using those actions to train our model here, and we're changing some of our parameters. So we have epsilon decay going here. We also have alpha decay, which is changing our learning rate, but we should be good to go. So let's do a shift enter here. Invalid syntax. Let's make sure that we have an extra guy here. Much better. So that compiles. But now let's get into training the network. So this is where we're actually going to run it. Kind of a bummer about the way the OpenAI Gym is working and the way it works in conjunction with Jupyter Notebooks is that it's not going to run very well since we already initiated the environment up here. So what we're going to do is we are going to copy our functions here, and we're just going to copy and paste them all the way down into one cell. So it'll start environment and run all at once. So I'm going to go through here and do this really quick. You should as well. So all I'm doing is highlighting the cells, Control C, and then I'm going to come down here and write it all in one cell. And we can take these print functions out here. We don't need to be printing the version every single time. So we have our imports here. We're going to have a couple more later when we import the specific layers that we're using for our neural network. We don't need this guy here. This is the environment that we initialized earlier, so that's the one that's kind of messing us up. We do need our parameters, so let's take these. We also have some more of our model information, so building the actual neural network. I'm going to take this, paste that down there, make sure these are good. So we're importing our different model layers, building our model. All right, so we have those. Let's take our functions that we defined. Control C, copy these down. And again, this is just because of the way OpenAI works. Once the environment's initialized, it wants to run all the way through, and so it doesn't have an easy time switching between cells to do that. But this should work just fine. Taking all these down here. So we have all of our functions. We have our run function as well. Now we just need to call it. So everything's defined in the run. What we can do is simply type run, and this will run this definition right here, this function, which has everything in it that we need. So if everything works well, this will start training. So let's see what we get. And again, Shift Enter. So we made a new environment. Well, that's an issue. Let's see, what line is this on? 95? There we go. That might work better. Looks like we're starting something up down here. Oh, that was the wrong one. Here we go. And so here we go. And you see it's ending pretty quick. So it stops whenever this pole gets to 15 degrees to the side. And it's not learning too quickly here. Because you can see our mean survival time is actually going down. Which means we have an issue with our model here. So that's no good. It looks like we are not lowering the epsilon the way that we should be. I think what we need to do here in this replay, yes, I should have a get epsilon here, so that it's using an updated epsilon each time. Because otherwise this epsilon's staying at 1, and it's just choosing a random action each time. This is why you see it's not getting any better. In effect, it's almost getting worse, because it's never using the model to choose an action. It's always going off that exploration value of epsilon equals 1 and choosing a random action. So let's see if this works better this time. So initializes. Here we go. So we're starting off poorly again, which makes sense, but there we go. So we're starting to see some improvements. Gradually getting better. And it certainly doesn't learn too quickly, but we are heading in the right direction. Getting much better at balancing it now. And remember, our winning number of ticks is 195. So this is going to have to get pretty good at balancing this. As well as it's a mean over the last 100 episodes as well. So the max number of ticks is 200. It's going to cut it off there. So even if we have one that tips over in, say, quick 10 ticks, that's going to kill our mean. So we're going to have to pretty much balance this perfectly each and every time, which our network is starting to do. So this is pretty cool to see, though. Our network is actually learning which forces it needs to apply to this little cart at the bottom in order to balance it. And look, it's doing very good that time. And it's using that information to update its parameters and train itself to do better and better each time. So our epsilon value is still probably not our epsilon min, so we're still going to take some random actions because we want to make sure that we are not stuck in like a local minima or something like that. So getting much better now. You're going to start to see our mean number of ticks go up pretty dramatically. And it looks like it's almost has it. We're only in not quite episode 100 yet. Remember, our max number of episodes was 1,000, so this has a while to go. It would be pretty disappointing if it didn't get it fairly well by that time. And so you can see it kind of get stuck into local minima where it's always pushing it off to one side, and that's why we really want to take some of these random actions. But overall, it's starting to do very well. So I'm going to let it go until we can see here, see it keep improving. The card pull certainly isn't as cool as maybe like an Atari game or a game of chess or checkers, but it's the same concept, so it's incredible to see it learn this sequence of forces to actually balance this. I mean, have you tried it balancing the pull on your hand? Not quite as easy as it would look. Certainly possible, though. This is a network that's learning to do exactly that very quickly. So we're only up to 63.11 ticks here. And again, this is averaging. This is actually our average over all of the episodes that we've run since we're only on episode 100. These first ones are a mean survival time over actually less than 100 episodes since we didn't have 100 episodes up until this point. But still getting substantially better. But let's talk a little bit about some of our principles of experimental design in machine learning. Let's say this converges in a couple hundred episodes and we hit our winning number of ticks. Does that mean we have the best algorithm out there? Certainly not. Furthermore, we might have the best model definition, but not the best parameters. So please play around with some of these hyperparameters and see if you can get better results. Changing the batch size, changing epsilon, gamma, or alpha, or learning rate are all going to impact how well our algorithm performs. What happens if you add another dense layer in there? So some of these things you can do to start doing that factorial search for the best algorithm. We really want to compare all of these different parameters and make sure we're optimizing them correctly. But remember again that this is training. So if I run this network, it's going to converge in a certain number of ticks, I'm assuming. And I've done this all the way through, so I know that it will. But that number of ticks or number of episodes is not going to be exactly the same for each training scenario. So really what we should do is run this a couple of times and take our average number of episodes to our winning criteria and then use that instead of just running it once. So if you're looking for the best parameters, you want to run it a couple of times. I know not everybody has that amount of time available, but ultimately that's what we should be doing. And this is actually a really cool part of OpenAI Gym, and one of the reasons that it was built. They have all these different environments that they encourage people to build different algorithms for and then post here so that other people can see how well you're doing. So some of these episodes before solve, 0, there is a way to simply solve this without machine learning, but some of these other ones have really good write-ups about what they did. And so this is a way for people to compare their algorithms and compare the results so people can start finding the best solutions. You know, OpenAI is kind of committed to making artificial intelligence research available to everyone. So this is a way that they are making it open source and available, in that they are comparing different people's algorithms through these different environments. So look, we're almost to our winning scenario here. We're at 145, so getting much better here. Although you see it still messes up sometimes. So it's not quite there. But still very good at balancing this pull compared to what it was when we first started. So I hope yours is up and training as well, and you are getting good results from it. I encourage you to play around with the hyperparameters, because they will really help you start to understand how some of these parameters affect the actual learning that's going on. Add some layers. Add a bunch of layers. Make a huge dense layer. Play around with it and see what you can get. This is kind of like the TensorFlow playground, where you're playing around with a neural network, and so you can start to see some of those different parameters actually affect your results. So hopefully this has been a fun tutorial for you. It was fun for me to make, certainly, and this class was certainly an enjoyment as well. So thank you for listening and following along if you have been doing so through all the lectures. I hope this has been a good introduction to machine learning, and that you can now use some of these features and program them in Python, just like we have shown through some of these projects. So it's been a pleasure. Thank you very much for listening. I hope your reinforcement algorithm is up and learning. Thank you very much.